In this video, we want to talk about the mean value theorem. So the theorem states, let f of x be continuous on the closed interval ab and differentiable on the open interval ab. Then there is a c that lives somewhere in the open interval ab such that f prime of c equals f of b minus f of a over b minus a. So let's look at this theorem and see what it really means. So consider this function f of x, and we have 2 points at a and b. Let's draw the line between a and b, and then let's put the point on the function where there's a tangent line that has the same slope as our purple line between a and b. This purple line is a secant line that goes between f of a and f of b. And that secant line is also what we know as the average rate of change, because we actually find the slope of that secant line, I should say, is the average rate of change. We find that slope by calculating f of b minus f of a over b minus a. So f of b minus f of a all over b minus a would be the slope of that secant line. And then the bluish line is a tangent line, and the slope of that tangent line is the instantaneous rate of change. And of course, the slope of that tangent line would just be f prime at c. And so from this picture, we see that at the point c, which lives somewhere in between a and b, f prime of c is equal to f of b minus f of a over b minus a. Now, what does this really mean? Well, it means that the instantaneous rate of change at C is equal to the average rate of change between B and A. So the theorem really states that for a function that's continuous on the closed interval AB and differentiable on the open interval AB, there is a C on AB where the instantaneous rate of change is equal to the average rate of change. And really this is saying that the slope of the tangent line at that point C is equal to the slope of the secant line between f of b and f of a.